Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 2 on congruence, Lesson 9, Side, 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 Triangle Congruence. The learning goal in this lesson is to see if we can prove one more set of conditions that guarantee triangles are congruent and apply theorems. There are two learning targets in this lesson. Number one, I can explain why the side, side, side triangle congruence theorem works. And learning target number two, I can use the side, side, side triangle congruence theorem in a proof. For glossary terms, we start with auxiliary line, an extra line drawn in a figure to reveal hidden structure. For example, the line shown in the isosceles triangle is a line of symmetry, and the lines shown in the parallelogram suggest a way of rearranging it into a rectangle. Converse. The converse of an if-then statement is the statement that interchanges the hypothesis and the conclusion. For example, the converse of if it's Tuesday, then this must be Belgium is if this is Belgium, then this must be Tuesday. Corresponding. For a rigid transformation that takes one figure onto another, a part of the first figure and its image in the second figure are called corresponding parts. We also talk about corresponding parts when we are trying to prove two figures are congruent and set up a correspondence between the parts to see if the parts are congruent. In the figure, segment AB corresponds to segment DE, and angle BCA corresponds to angle EFD. Parallelogram, a quadrilateral in which pairs of opposite sides are parallel. Now that we're done with the introduction, let's take a look at the practice problems.
Some people say this is too complicated, but when we invest in our communities and our education, we can solve any problem. Let's start with this one.
Practice problem number 1 says a kite is a quadrilateral which has two sides next to each other that are congruent and where the other two sides are also congruent. Given kite WXYZ, show that at least one of the diagonals of a kite decomposes the kite into two congruent triangles. So first, we notice that WX is congruent to WZ. So WX is congruent to WZ. Then we know that YX is congruent to YZ. Now, if I were to draw a line WY, then we can go ahead and say that WY is congruent to WY because they are the same line. So now I know that if I just reflect across WY, places triangle WXY on top of triangle WZY. Due to the side side triangle congruence theorem, triangle WXY is congruent to triangle WZY. So we already knew that two pairs of sides were congruent. We created the third side that was congruent by drawing segment WY, and obviously a line is going to be congruent to itself. We know that reflecting across WY means that we will have two congruent triangles, so this also proves the side-side-side triangle congruence theorem, which proves the two triangles are congruent. I hope this makes sense to you, but if you do have any questions, please feel free to leave a comment below.
You kids have it easy. Back in my day, we didn't have calculators. We had to use our noggins.
Practice problem number 2. Mai has proven that triangle WYZ is congruent to triangle WYX. Using the side-side-side triangle congruence theorem, why can she now conclude that diagonal WY bisects angles ZWX and ZYX? So, if she has already proven that the two triangles are congruent, then we can go to the next step, which is that corresponding parts of congruent triangles are congruent. This means that angle ZWY is congruent to angle XWY. And we know that angle ZYW is congruent to angle XYW. If the angles are congruent, then WY must be the angle bisectors by definition. So we're just taking the information that's given to us, which is that the two triangles have already been proven congruent, using the next piece of information that we know, which is that corresponding parts of congruent triangles are congruent, and showing that if the angles are congruent to each other side by side, then the line splitting them by definition is the angle bisector. I hope this makes sense to you, but if you do have any questions, please go ahead and leave a comment below.
I'm once again asking you to solve this equation, and don't tell me we can't afford to get to the answer.
Practice problem number 3 says WXYZ is a kite. Angle WXY, that's this angle right here in red, has a measure of 133 degrees. And angle ZWX, that's this whole blue angle, has a measure of 60 degrees. They want us to find the measure of angle ZYW. So they want us to find this angle down here. So here's what I know. I know that by side, 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 then these two triangles are congruent. So my first statement is if angle WXY equals 133 degrees, then angle WZY also equals 133 degrees. So I can draw that in. My next statement is that if angle ZWX equals 60 degrees and segment WY is the angle bisector, then angle ZWY is 30 degrees. Because half of 60 degrees is 30 degrees. Now I know that by the triangle angle sum theorem, angle WZY plus angle ZWY plus angle ZYW must equal 180 degrees. Well, I know that the first one is 133 degrees. I know that the second one is 30 degrees. So I just need to find angle ZYW. 133 degrees plus 30 degrees is 163 degrees. I subtract 163 degrees from both sides, and I find out that angle ZYW must be 17 degrees. I hope this makes sense to you. Remember that once you know that two triangles are congruent, then corresponding angles are also congruent. Remember that if you have an angle bisector, then it divides an angle in half. Remember that all three angles inside a triangle must add to 180 degrees. And you can go step by step using the information that you have to find the information that you don't have. Let's review the learning targets to make sure that you know what you need to before moving on to the next lesson. Learning target number 1, I can explain why the side-side-side triangle congruence theorem works. And I'll explain it in 2 ways. The first way is that if you have 3 congruent sides forming a triangle, then the only way that those lines at those lengths can form a triangle is if the angles are the same. So if all 3 sides are the same and all 3 angles are the same, then those triangles are congruent. The other way that you can explain it is by understanding that if I have 2 triangles and I know all 3 sides are congruent with their corresponding sides in the image, then I know that there is some series of rigid transformations that can make the first triangle lay directly on top of the image triangle. Learning target number 2 says that I can use the side-side-side triangle congruence theorem in a proof. And we did this in the practice problems, where we said because we know that the triangles are congruent using the side-side-side triangle congruence theorem, then we could go on to talk about congruent parts or corresponding parts of triangles being congruent. We could then prove that other angles were also congruent. We could go on to prove that line segments were bisectors of angles. So this is how you would use that specific theorem in a proof. If you still have any more questions, please leave a comment below. If you found this video helpful, please give it a thumbs up. In the bottom left of the screen, you'll see another video that YouTube thinks you might find helpful as well. And in the bottom right of the screen, you'll see the subscription button. It really would help out the channel if you would subscribe. I look forward to seeing you in the next lesson.